Hello, everyone. I don't have time to go through all of the solutions to all of the homework on this video, but I will do a few triangles and a few simplified problems. I'll be taking my simplified problems straight out of the quiz. I'm sure someone's excited about that. But before we get to that, I thought we would analyze a few pyramids. Just more interesting than doing a triangle by itself. Okay, so if you want to follow along at home, this is example 8 out of the topic 3 notes that are posted online. So this is the Pyramid of Khafre. Pyramid of Khafre. This may have been the first successful pyramid constructed. Of course, a little bit of doubt about that all the time, but you know, it may have been. Okay, so what we know about the Pyramid of Khafre is that it is 143.5 meters tall. And the angle that it slopes up at is a 53 degrees. So that's pretty sharp, but you notice it's not a huge pyramid either. Definitely imposing, but yeah. Anyway, so let's draw a picture. Of course, the pyramid actually does that, but we only need half of it. So we'll solve a right triangle, and if we need the length of the base, we'll double it. 3 degrees, and this is 143.5. Now, one question you might ask yourself is it wider than it is tall? Or is this distance longer than this distance? And we can think about that by saying, well, at 45, they would be equal. This is greater than 45, so this will be greater than this. So if I call this delta x and this delta y, just by reasoning, we've discovered that delta y is going to be greater than delta x. So that's what we expect to find. If we find that, then we have some more confidence. Okay, so this is opposite over adjacent, so we're going to use the tangent of 53 degrees, and the opposite would be 143.5, and the adjacent would be what we're solving for. We'll call it change in x. What should I say here? There's no reason not to solve this angle instead, this 90 minus 53 over here. One more subtraction, one less subtraction. Don't see much of a difference. Plug in a 37 over there and you should be in shape. Switch your opposite and adjacent. But excuse me, but I've already got this set up like so, so we'll solve it. My change in x is going to be equal to 143.5 degrees divided by the tangent of 53 degrees. And we get a length of 108.135 meters. And that is half of the length of the base of the pyramid. So we can multiply that by 2 to get the whole length of the pyramid. So length of base is 2 times 108. We'll call it 0.1, and that is going to be 216.2 meters. Pretty big structure. Not quite a football field, or 2 football fields-ish. All right, so maybe we should find the length of the slope too. I'll call this h for hypotenuse. All right, so now we have a choice. We can use Pythagorean theorem. I think in the spirit of reviewing trig more, I'm going to use the sine of 53 degrees is opposite over hypotenuse. And in our picture, that's 143.5 divided by our unknown h. And so h is going to be equal to 143.5 over sine 53 degrees. And we should come out with about 179.68 meters when we perform that computation. Remember to be in degree mode in your calculator. Let's see, flipping through my notes. Let's do another good one here. Okay. I'm trying to save you guys from doing the bent pyramid. We've already discussed that. Let's see here. I have, okay, this one's neat. Similar to the bent pyramid problem, but a good one. Okay, so there's a full kind of solution of a basic trig. Let's talk about this one. This one is also in the trig supplement packet. Yeah, so we have that someone named Morgan is out for a walk in Chicago. So here's a person out for a walk in Chicago. They're so far away from a building. They sight on that building, and they get an angle of 3.6 degrees. And then they walk 1 kilometer this way, 1 kilometer. And they measure again. And they get 4.2 degrees. Now, clearly this picture is exaggerated for scale. These angles are much bigger, but I hope you see the point there. Okay, so our question is, how high is this tower? I will call this height. No. We use that for hypotenuse. Let's call it delta y. So the change in y. Okay. Well, at first, there's no direct path to the solution. So just like with the bent pyramid, we kind of have to start playing with the information we're given. The information we're given is that the tangent, well, the information we can deduce, I guess. Oh, whoop. The tangent of 4.2 degrees, well, that's going to be delta y over, okay, now we have to be careful. We have to call one of these distances, I'm going to call this delta x2, because it's the second delta x. I'm going to call this delta x1. All right, so then this one is the second change in x, if you will. And we also know that that tangent of 3.6 degrees, that would be the same delta y, but over a delta x1. And we know a little bit more. We know that x1, delta x1, the change in x1 minus the change in x number 2 is equal to 1 kilometer. Okay, 3 equations, 3 unknowns. And so I can start setting things up like, you could say this is delta x2 is delta y over tangent 4.2. You could say delta x1 is delta y over tangent 3.6 degrees. All right, so now I have delta x2 in terms of delta y, delta x1 in terms of delta y, and I have those two things related by a known quantity. Known quant. Okay, so then I can, if these are truly equal, and we've established that they are, and we have this relation, let's just fill in the pieces, right? So I have that my change in y for delta x1 over the tangent of 3.6 degrees minus the change in y over the tangent of 4.2 degrees is equal to 1 kilometer. In other words, that change in y we're looking for is 1 over the tangent of 3.6 minus 1 over the tangent of 4.2. And that's all equal to 1 kilometer. So delta y is equal to 1 kilometer divided by 1 over the tangent of 3.6 minus 1 over the tangent of 4.2. And that computation results in a value of 1.439 kilometers. 1.439 kilometers. All right, so that one's a little trickier, but the same idea. Yeah, I think we'll leave it there. Maybe I'll do one more. This one is also from the topic 3 notes, and it's investigating the 3-4-5 triangle. Let's find it. All right, there it is. So kind of step out of the real world. Let's just talk about numbers and theory and how to do this stuff. All right, so we have a triangle. It is right, not wrong. And the short leg is 3, the long leg is 4, and the hypotenuse is 5. 3-4-5 triangle. So this is going to have the same angles as a 6-8-10 triangle, as we discussed the other day, or any other multiples. So let's start naming angles. I call this theta and this phi, or phi, depending on your philosophical bent, I guess. Then I can see that I have the tangent. Oops. The tangent of theta is going to be 4 divided by 3. The tangent of phi is going to be 3 divided by 4. And I could set up some other ones like cosine of theta is 3 over 5, and the sine of theta is 4 over 5. Cosine of phi is 3. Is 4 over 5. Sine of phi 3 over 5. So you see, when we switch our perspective, we switch our ratios. Okay. So what do we want to do here? Well, we want to find all the angles. Well, I got one there. That's 90. Okay. Good start. So we can pick any. We've been dealing with sine too much, or sorry, tangent, I think, too much in the example. So I'm going to use cosine and sine for this, and we'll solve for phi, say. So I know that the sine of phi is equal to 3 over 5. So then the sine inverse of phi, can't write that. That's the wrong input for an inverse function, right? I have to input a ratio. phi is equal to the sine inverse. Some dripping happening in the room. Sine inverse of 3/5. And the sine inverse of 3/5 is going to get me an angle of 36.87 degrees. All right. So I used sine for one of them. I guess I'll use cosine for one of them. So cosine of theta is also 3/5, interestingly enough. And the cosine, so then theta is equal to the cosine inverse of 3/5. And if we compute that, we come out with about 53.13 degrees. We could have also said 90 minus phi is equal to theta. Okay, all right. That's some triangles analyzed. Now I'm going to move on and do some stuff from quiz 4. I'll do 3 problems from the first page of quiz 4. So I'll take, so we'll do 1b. So first I'll rewrite the problem, x to the 3rd, y squared, 4x to the minus 2, all to the 1/4 power. And we could write that as the 4th root of all that stuff, but won't help us. So the idea here is that no fractions, and this was a little unclear, but what I meant was no fractions as far as this fraction is concerned. You could have fractional exponents. That was acceptable. So we did that one homework problem where you simplified inside the parentheses and then outside the parentheses. Doesn't matter which you do, but it might make a problem more or less convenient. So in this case, we're going to simplify inside the parentheses first. And so I'll be using the rule, I'll be using the rule a to the n divided by a to the m is equal to a to the n minus m to start off. So I'm moving everything to the top here. So I have x cubed minus a negative 2, because it's negative on the bottom there. I have y squared, nothing new there. And I'm also going to use the jump the line, change the sign rule. 1/4 first, or 1/4 to the first power is equal to 4 to the minus 1 power. And this is the a to the minus n is equal 1/a to the n rule. So I'm just going to put that up top, 4 to the minus 1. Now everything's over 1. I'm happy with that. I've kind of accomplished my no fractions thing first. Go ahead and simplify that. So x to the 3rd minus a negative 2, x to the 5th, y squared, 4 to the minus 1 to the 1/4. Now I'm going to use the rule a to the n to the m power. So I have a to the n. I put it all to the m power. End up with a to the n times m. So distributing the 1/4 through in that manner, I get x to the 5/4, y to the 2/4, which simplifies to 1/2, and 4 to the minus 1/4. And that's good enough. Any decimal answer you put of this will take longer to write and be less accurate than 4 to the minus 1/4. If you wanted to, I just like that. That's fine with me. One of the ideas here is that these all mean the same thing. If you've done your algebra correctly, these answers are identical. All right, so now I'm going to do 2a. All right, so we started out with a to the minus 2, b cubed, a to the 5/3, b to the minus 1. And we want no negative exponents. Okay. So let's start by getting rid of all of our negative exponents. Okay. So we're going to jump the line, change the sign twice, right? There and there. So jump the line with A, we get, so jump the line with B and A, we get B cubed, B to the positive first power, and A to the 5/3, A squared. Okay, so now, so we used the A to the minus n is 1 over A to the plus n rule there twice. So now it's a matter of combining. So it's just A to the n times A to the m equals A to the n plus m. All right, so I have B cubed plus 1, or B to the 3 plus 1, and that's divided by A to the 5/3 plus 2. Now, that's the same thing as B to the 4th divided by A to the 5/3, and there's 3/3 in each one, and I got 2 1s here, so that's a total of 6/3. And in the end, I get B to the 4th divided by A to the 11/3. And there you go. All right. One more page. I just want to take a look at one of these log ones. 3A. All right, so log of x, and when there's no subscript, we know that's a log base 10. So log 10 of 10x equals 5 is just like just writing the log of 10x equals 5. Now there's kind of two ways to go about this. There's sort of a conceptual way where you say to yourself, well, I know log gives me how many powers of 10, or log base 10 gives me the answer to the question, hey, this thing in my argument, this input here, how many powers of 10 do I have to put that to get that number? Well, 5. The answer is 5. So from that, you know that whatever 10x is, it's the same thing as 10 to the 5th power. What power do I have to put 10 to get 10x? Well, 5. Okay, and from there you can just solve. So I have 10 to the 5th divided by 10 to the 1st. That's 10 to the 5 minus 1. And that's equal to 10 to the 4th. 10 to the 4th is a great way to write your answer. And remember, it's no different from 10,000. It just looks different. Everything's the same thing but different and all that. All right, I think we're going to leave it there. I'll see you guys in class on Monday, and I'll have this video posted later on this afternoon. Take care.